When finding a polynomial given its specific zeros, we are essentially going backwards from the normal steps of solving an equation. This means instead of solving an equation and getting answers, we are taking the answers and getting an equation. So essentially the steps of solving an equation, we're going to go backwards. So we're going to find a polynomial given the following zeros and degree. The polynomial is of degree 4 with zeros at 3 with multiplicity 2, -1 with multiplicity 1, and 0 with multiplicity 1. We're going to also use the fact that f of 1 equals 16 to find the leading coefficient a. So we'll come at the second part later. So let's deal with the first one. We're having a polynomial of degree 4. That means there's going to be x to the 4th power. So we have 3 with multiplicity 2. That means we have x equals 3 and x equals 3 again because it happens twice because it's multiplicity 2. We also have multiplicity of 1 for -1 and 1 for 0 as well. So x equals -1, multiplicity 1, and then x equals 0, multiplicity 1. So now I'm going to take all these and go backwards. So normally we would solve for x, but now I'm going to get all these equal to 0. So x minus 3 equals 0, x minus 3 equals 0, x plus 1 equals 0, and this is just x equals 0 because it's 0 already. And now since each one of these is set equal to 0, I'm going to bring them back together as 1. So x minus 3, x minus 3, x plus 1, and I'm actually going to put x in the front here, equals 0. And again, I'm going to simplify it just a little bit more. So I'm going to have x minus 3 squared, and x plus 1 equals 0. So I brought everything back together. Very simple, very easy. That's a polynomial. Now, the second part here is use the fact that f of 1 equals 16 to find the leading coefficient a. Now, this is my polynomial, but it could have a scalar multiple in the front. It could have a 3, it could have a 4, it could have a negative number. It could be -1. It could be many things. We don't know. So what I can say is that my polynomial here, f of x, is equal to some unknown coefficient times x minus 3 squared, x plus 1. Now this is correct, but I need to know what a is, and I can figure out a by the fact that I know that f of 1 equals 16. So I'm going to star this for later so I can come back to it. And I'm going to use the fact that f of 1 equals 16 to find a. So f of x is just going to be 16 equals a. And then I'll replace all the x's with 1. So 1 times 1 minus 3 squared, 1 plus 1. And so just work it out and solve for a. So a times 1 is a. 1 minus 3 is -2 squared. And then 1 plus 1 is just 2. And so -2 squared is going to give me 4 times 2. And then I can bring 4 times 2 together. So 16 equals 8a. And now I can solve for a by dividing 8 over, and I'm going to get 2 equals a. So now I know what a is, so I can go back to where I started before and replace a with 2. So that's what I'm going to do. So my function, f of x, has a coefficient of 2 for a, x minus 3 squared, x plus 1. And this would be the polynomial that fits the conditions of this question here, with the zeros given and the fact that it gives me some more information so I can find out what a is. Now, Let's do another one. The polynomial is of degree 3 with zeros at 1 minus I and 2. Well, that's only 2 zeros, and it gives me no information about A, so it means I don't have to worry about it. I can just focus on this. When you have something like this, dealing with complex, and the fact that it says degree 3 and I only have 2 zeros, you need to be aware that complex zeros always have a pair. So x equals 1 minus I, and it has a conjugate pair, 1 plus I, and x equals 2. So when you're only given one complex zero, you know that the conjugate pair is the other part that's missing. Always and forever. Now we're going to deal with this by bringing it all back together. So x minus 1 plus I equals 0. X minus 1 minus I equals 0. And x minus 2 equals 0. Again, I'm going to multiply everything together. So x minus 1 plus I, x minus 1 minus I, x minus 2 equals 0. Now before I didn't multiply them all together because it was good enough, but because I have complex numbers here, or complex letters, I don't want to have that. So I'm actually going to distribute everything out. And what you should do is you should always multiply the complex numbers or factors together, because that will cancel out the i's later. So that's what I'm going to do. So I'm going to get x times x, which is going to be x squared, x times negative 1, negative x times negative I, negative xi, then negative 1 times x, negative x, then negative 1 times negative 1 is positive 1, and then negative 1 times negative I is positive I, and then I times x is xi, I times negative 1, negative I, and then positive I times negative I is negative I squared, x minus 2, 0. Now, doesn't look much nicer, but this is where the nice part comes in. Any term that has an I should cancel or change forms. So, I have xi negative and xi positive. Cancels. I have a positive I and a negative I. Cancels. And then I have an I squared. And we have to remember that I squared is equal to negative 1. This is a very important fact, otherwise you would not be able to do this, so you need to know that. So combining the like terms and changing forms, x squared minus 2x plus 1 minus a negative 1 for the I squared, and then x minus 2 equals 0. And this is just a double negative, which is just going to give me a positive, like so. Combine like terms one more time. Minus 2x plus 2, x minus 2. And then we're at the last part where I'm going to distribute all of this together so I can get a single polynomial. So x squared times x cubed, x squared times negative 2, negative 2x squared, negative 2x times x, negative 2x squared, negative 2x times negative 2 is going to give me positive 4x. 2 times x is 2x. Then 2 times negative 2 is negative 4. And now I just combine like terms one more time, and I will get my function. So f of x is equal to x cubed, the only one I got there, negative 2x squared and negative 2x squared, negative 4x squared, 4x and 2x, going to give me 6x, and then negative 4. And that's all there is. So this is the polynomial that we get from the information, a degree 3 with these given zeros.